Okay. What happened to my background? I had all this set up, and now it's just not showing. No, it's there. Oh, I went to the wrong place. There we go. Much better. Alright, so, tonight I have good news. For me personally, it's more of professional slash research news. My first research project for my dissertation was accepted at a major conference, which is fantastic. Uh, the conference only required me to submit an abstract. I have to submit the full paper by the end of February. I have proof of concept already of this particular part of the dissertation that I have full confidence in the paper and the results and all that stuff. But I need to actually get everything done. So I have the paper written. I have I have the introduction written. I have the abstract written. Um, but I need to get results, and I've got preliminary results here, which speak of the actual research. What I'm doing is I'm creating an AI model that is analyzing spectrometry data from the Mars rover. So basically, what it's the job of the model, of the machine learning model of the AI, is to be able to categorize um, the spectrometry and whether or not you have certain I don't know, categories, labels, contents in the spectrometry if a certain element exists. Not like an element in the periodic table, but an element like if there's an aromatic uh detected within the spectrometry. Carboloc carbo I can't even say that word. Um but chlorine bearing compound, things like that, which actually I think the chlorine bearing compound is the carrier, um, hydrocarbon, etc. I'm no expert in spectrometry. I've actually had to learn throughout my work on this research. But I've learned a lot with spectrometry, and I'm basically, it's for me at least, it's more about seeing if I can apply a model in this domain and make it effective, or at least more effective than existing research. And these results are very, very promising. Ultimately, I think we have a winner. However, I need to get it done. Now, when I last left off this research, I actually put a pause on the actual coding. I put a pause on the actual testing and training of the model because I wanted to get the abstract done. I wanted to get a piece of the research done uh, in order to do it, or in order to I get the paper moving. I had the model moving. I wanted to get the paper moving. So I put a pause on the model, and now I forgot what I was doing. I paused it early, so I only got 4 epochs in to training, which I mean, astounding, absolutely astounding progress for just 4 epochs of training. I guess 5 technically. I didn't offset epoch 0, but anyways. However, it takes so long for a single epoch, and I discovered there were more metrics I wanted to include. I don't remember what those metrics are, and that's killing me. I do not remember my metrics. So I have to think a second and figure out what I wanted to implement. It would have been really useful if I'd written it down. I don't remember. Anyways, let me get some music going. This is basically just going to be chill. And we will you know, it's kind of like chill code. Alright, let's see here. I think it had to do with specifically the metrics that were being used. Oh, right. So the previous results I'm comparing against, it's data-driven, it's GCMS. It was this competition is basically what I'm doing. Wow, that is really bright when you compare it to the darkness I was looking at earlier. Ooh, I can do something about that. There we go. This is an example of the spectra and kind of like the results. And I'm basically looking to beat first place, which is not going to be hard because, no offense to first place, but they're using what's known as a convolutional neural network, which is mostly designed for image processing. And GCMS, or gas chromatography mass spectrometry, has a time series aspect to it. So the intuition I had going into this research was maybe we should be applying a model that is more tuned to time series rather than using a CNN. And when you look at research from pretty much any domain, all machine learning models kind of started with a CNN. That was like the go-to. So when you see a domain and the newest or latest and greatest is a CNN and it's not an image data, chances are they're lagging behind a little bit in the machine learning technology, which is the case in space science, ironically enough. So let's see here. I was looking for the results. Log loss was definitely one of the metrics I wanted to have. So I already have precision. So I need to basically do log loss, and the reason why that's relevant is because when we look at what I'm already doing, I'm actually doing, my loss function is focal loss, not log loss. So I cannot compare this focal loss number to the log loss number for the others. I need something more accurate. So I'm training off of focal loss, and that's great, but I need to record the log loss score so that I can compare my model with these other ones and say, oh, you know, it's better or it's worse, etc. As for precision, I mean, it's already up there. When you look at precision from a total score, again, just 5 epochs. Where's my precision? It's not loaded. I'm running this whole server off of my own personal server, and it's going through externally. So it's just like, it does not want to load. Being very poor about that. So this is my server. If we local host it here, we might get better results. And I might just go through this to look up the actual stuff. And score, where's my precision? There. Like, you can see that right here, this is absolutely nuts. This is what really shows that my model is doing amazing. Because after 5 epochs, the precision is, it's 99%, 99.67%. And when you look at what the precision is for the winners. The highest precision was 80%. So like I've already blown it out of the water in 5 epochs, but I need that log loss score for a final comparison, and that's what I was missing. Now the real question is, was there anything else that I wanted to add? This won't load at all, man. All right, so we'll ignore this and just go through parsec. So I have accuracy here for each subcategory. I don't know if accuracy is what I want. Is log loss really the only thing I wanted to add to this? Surely there was another metric. Recall is not important. I mean, recall is important, but it's really not all that important. The problem with the accuracy metric, especially when you have a highly imbalanced data set, is that if you were to just say, well, talking binary true or false, which I guess each one of these individuals is, if you were to just say false all the time, as in it doesn't have this item, because of how imbalanced it is, if it only has that one category 1% of the time, and the AI just comes back as no, it doesn't have it, that means it's 99% accurate just by defaulting to no. So accuracy doesn't tell you too much. I mean, clearly you can see that in certain cases the accuracy definitely improves over time, but in other cases, I mean, did it even predict anything for the alcohol attribute? Or is this just false all the time? That might be a problem I'd like to solve, just to validate what I'm seeing. And what I might do, excuse me, is switch these to precision. That might be a better metric. Instead of accuracy, I might switch the per category metric to precision or F1 score. Might do F1 score. How did my F1 score work? It does increase, so yeah, we'll just do F1 score. I think that'll be a better tell of if we're predicting anything at all for each of these categories, because I don't need to know how accurate it is for each. The overall accuracy, I mean, it's already up there just because. So we'll do F1 score. That's fine. So switch the per category metrics to F1 score. Add log loss as a metric and overall log loss as a metric. And really that's it, right? If I train with log loss and precision, I have my comparisons. And I could definitively say if I beat these numbers. And from there, From there, it's just writing the paper, really. Is there anything else, any other data I want in the paper? Oh, well, I say that, okay, so that's in training. I do need to write an inference routine that can infer on the actual validation or testing data that was used for the competition. So to give kind of a a setup. There's 3 different types of data. Oh boy. All right. Cool. There's 3 different types of data that they give. They give train, and I think it's a validation. Right, so you have a train data set, and then you can validate while training to see how you've improved. And then when you have your final model, when you have your final weights, you pass it on the test data set, and that's kind of like your how well did you actually do? Are you what do they call it? Over what I'm blanking. When you fit too tightly. Wow, I work in AI, like a freaking, I can't even think this. Whatever. Anyways. So, I'll go ahead and make those metric changes in my model, and then we can get to the actual stuff. My model is not very well documented. I don't know if I should apologize for that. It really kind of is what it is. So I want to change these to F1 score. I need a log loss. In order to get a log loss, I'll have to use a log loss function. That's the default loss function. I believe in here they actually say what the loss equation should be. I want to make sure I match it exactly. I might have to go find my paper. So second place actually wrote a paper. It's a little skinny. But second place in this competition did write a paper, and I believe he might say the log loss function. There it is. A performance metric, or performance is evaluated according to a multi-label aggregated log loss. Well, obviously. Or cross entropy loss. See, I started with cross entropy, but it's such an unbalanced data set. It actually happened during work. I was working on a different model for work, for traffic incident prediction, ironically enough. That's also a hugely imbalanced data set, and log loss really did it. Like, it makes a difference. But cross entropy is kind of just like your generic categorization. This statement isn't exactly correct. Cross entropy loss, I suppose it does do this, but log loss is much better than that, I think. What log loss does, or not log loss, what focal loss does is it's basically saying, I don't care about recall. I only care about precision. So what that means is, if it gets only 1 true positive, but 0 false positives, that's a precision of 100%. And it would prefer that over 2 true positives and 1 false positive, right? Because 2 true positives and 1 false positive, that's a precision of 50%. And so it tries to basically kill all the false positives as much as possible. It doesn't care as much about getting everything right. It just wants to know that when it got something right, it was right. It's hard to describe. It's really, really good for highly imbalanced data sets where false positives are really bad, effectively. But anyways, we gotta implement this. What I need to figure out is if PyTorch's cross entropy is this equation. What is it? for binary. Okay, let's. Do I have Gemini? I do. Gemini's off screen. I'm gonna ask him off screen, just in case Gemini says something I don't want them to say. All right, come on. In PyTorch, what is the equation for binary cross entropy loss? Well, the built-in binary cross entropy loss. In PyTorch, the binary cross entropy loss measures the difference between two probability distributions, the ground truth targets and the predicted probabilities. The mathematical formula is negative squiggly w that I don't actually know the name of n y times log xn plus 1 minus yn times log 1 minus xn. I think that's actually the same equation. I might just be able to use the built-in log loss. Because in this case, the squiggly w is 1. I'm going to sneeze, hold on. I stifled it. Oh, that's the worst feeling in the world. All right, so it's this extra term. Here, I'll just real quick so you guys can see what I'm looking at. It's this extra term right here that has me concerned. I actually learned something new yesterday. I can split view. So the question is, what is P in this situation? Normally P is the probability, or Y is a binary variable indicating whether the label is correct, and P is the user predicted probability that the label is present. So XN, so this would be P. Okay, so yeah, that matches. So what is this? An optional weight. Optional defaults to 1. Okay, yeah, so I can just use the binary cross entropy. That confirms it. I don't have to implement this manually. That was the question. For research, do I have to implement this equation manually, or can I use the built-in PyTorch BCE? The answer, I can use the built-in PyTorch BCE. So let's separate the views, move Gemini back over here, and go into here. I need to basically aggregate the log loss from all the different... How do we do this? I mean, yeah, I think that's really it. So just do log loss. That feels wrong. So we want the input tensor, that's fine. Probably should be fine, right? Let me make sure. I just want to be extra sure. This might be the wrong BCE. I think it might need to be like capital BCE. It does a sigmoid, which actually that's fine. BCE with lost logits is a sigmoid. Which is, again, I'm fine with that. Although, where does it get, like, BCE with lost logics? I don't really think it matters. And then we'll have to do an average lost logits. I don't want to separate these. Well, you know what? No, I am going to do this because here's the deal. I would have a sigmoid layer in my model if it wasn't for the loss function. In fact, I will be sigmoiding out my output. I can't speak. I will be applying sigmoid to my outputs before presenting them. So in my mind, sigmoid is part of my model. So yes, this is exactly what I'd want to do. Right? I'm still doubting myself. I need it to be perfect. That's the problem. That's the problem with research. It has to be perfect. Yeah, so it just sigmoids your output. Yeah. Yes, I'm happy with that because my output would be sigmoid if it wasn't for how I was doing loss. So yes, I'm happy with that. And effectively, we're just going to copy paste how we were doing our loss calculation, which I believe just hold out till we get to here. Yeah. All right, so we'll just do this. Averages it, then we can throw it down here. There we go. That should take care of everything. Alright, the second thing I wanted to do was I wanted to replace accuracy with precision. Where do I calculate precision? Hold on, I'm gonna cough again. Do I not keep it on a per item? No, this says per item. I haven't looked at this code in a month. I'm so out of it. R out. Label and R out. If label equals R out. Accuracy equals 1. The R out is rounded. So R out is the rounded output. The rounded output is likely... Yeah, it basically flattens it to 0 or 1. So that stands for the rounded output. So this is a singular number? No, this is an array. No, this is an array. This is a singular number. And we get a singular number here that we're just throwing into a grand average. What I should be doing is throwing it into an array instead of a grand average, and then I can just change this code here to sum up the array into a single value and then divide by count. Is that right? Is this math all right? If that's 1 or 0 and that's 1 or 0, then your precision here is either 0% or 100%. It's either 0 or 1. So how does the average precision... I'm seriously questioning this math. If I were to do this a different way, how would I do it? Right? Because precision score... It's a number of true. It's an array of true. And an array... It's an array of your ground truth and an array of your predictions. And what your labels are, but my labels are 0 and 1, so that's not necessary. I might need to... I need to run this. End it. Hopefully everything is configured the way it needs to be. What's my parameters at? Good, I'm using the transformer, that's the important part. Learning rate's kind of low. I feel like that learning rate should be 1e to the -1, but we'll see. I don't remember. I don't remember. But it takes a long time. Not only that, but it's gonna be trying to talk to my ML flow, which isn't even here. It's hard-coded, I guess. Alright, well, while this runs, I'm gonna think about this math and see if I can figure it out. Because if this is wrong, then my recall is wrong too. And so is my F1 score. But again, that doesn't make sense because, I mean, average precision ultimately becomes a 0 or 1, right? For that one test, it's either 100% or it's 0%. And then precision becomes the number of 100% divided by your count. Which might actually be accurate when you think about it, right? Because, like, if you're 100% precise, well, it's almost like it's an exclusive or. Because if your precision is 0, if your label is 0 and your R out is 0, then your precision is it 1 or is it 0? I guess that's the really big question, right? It should be 0, or it should be 1. So if your label is 1 and your R out is 1, your precision is going to be 1. If your label is 0 and your R out is 1, your precision is going to be 0. If your label is 0 and your R out is 0, your precision should be something. I'm assuming it's 1. Sets the value to return when there is a 0 division. I think that's what that does. So if that's 0 and that's 0, you get a 1 that goes there. So what if your label is 1 and your R out is 0? That should still result in a precision of 100%. Right, because you're dividing by 0. What's the equation for precision again? It's true positive divided by true positive plus false positive. No. Yeah, true positive divided by false. Yeah, right there. So, I mean, it would still be divided by 1. So then if you're... Yeah, we should have CUDA going. Oh, I wonder if I killed my stream doing that. Did I kill my stream doing that? Huh. I wouldn't be surprised. Alright, well, if I killed my stream trying to train on my computer, I apologize. It would use the graphics card, so that would make sense. Welcome back. During that entire time, I figured out that this precision is accurate, even though it's only dealing with a single instance of a single item. The only time precision would be 0 is if there was a false positive. And that would be accurate. And so, effectively, this average precision, when you divide it by the count, becomes accurate. Because it's the number of... This only goes down if you have a false positive. Otherwise, it'll just be 100%. And yeah. So that makes sense. And I think recall is going to end up being... going the same way here. True positive... divided by true positive plus false negative. Still, I think that's all correct. So really what I should be doing is I need a per label precision. So if I change this from a global summation to a per label summation, and then I can split it down here, I can do a summation of all values in the array divided by the count. That'll give me the global average precision. But then I can do the exact same thing down here. I can say the values of a single index divided by the count will give me the per label precision, and then I can replace all these with precision instead of accuracy. The real question I have is, how is this an array? What magic made that into an array? Because R out is not an array. God, I really wish I could test this and debug it. It'll just burn my capture card out. I gotta think it through instead. Because this is an array. But I pull a single item out from the array. And I pull the label out. And accuracy, so this would be a true or false value purely based on a single item. How does average accuracy become an array? I mean, it clearly does. You just have to go back and look at the metrics to see that we have per label accuracy here. Actually up here. Vectorization math really messes with my head. We initialize the array here. The numpy array. Like, this made sense to me when I wrote it, but I cannot, for the life of me. I need to debug this. I suppose I could use CPU instead of CUDA. But then it would... I don't gather these metrics on training. I only gather them on testing. I'd have to wait for an entire epoch. Alright, let's think this through. Average accuracy is a numpy array. We confirmed that right here. Did my glitch go to sleep? Must have. I didn't realize I don't have it on stay awake mode. Anyway. So we have a numpy array coming down into here. Then we're saying the numpy array is the numpy array plus a singular value? Well, hold on. That first parameter of np.zeros. That's shape. I switched this to an array of 1. So if it's an array of 1, how am I doing this? That would be an index out of bounds. That makes 0 sense. I mean, very clearly, I used to... Did I? Yeah, I used to make it an array for each label. And then I switched it to 1. What? I think this is wrong. I think this is wrong. So then, how would I undo this? This is what happens when I step away for way too long. We could probably vectorize all of this. What this really should be is average accuracy I equals average accuracy I plus accuracy. And that would give us our array. That's probably the only change that's needed to fix this. I don't know why that changed in the first place. Alright, I'm being called upstairs for reasons. I need to basically this, most likely, to make it per label for accuracy. ND array does not define, but NP label is an ND array, isn't it? Whatever, it's ilock. No, I get it. It's ilock. You're supposed to use ilock or whatever. I'll have to solve that later. Alright, guys. I'm going to call it. I mean, it was a quick hour-ish long stream, right? For the night. I was able to catch up to what I needed to do, understand where I was going. Those are all very important things. I'll probably be doing more work on this tonight. I don't know if I'll be going live. We'll see. trying to see how long I've been streaming. I started about 10:20, so yeah, it's been about an hour. That's not terrible. Alright, well, if you're lurking, thanks for watching. Hope you all have a wonderful night. And I will see you guys tomorrow.